Welcome back, CIS 1400, and welcome to Module 7. Hopefully you had a good time getting through the first project of the year, the reverse guessing game, and you didn't find that too complicated. Either way, it's time to move forward, and we're getting into some more complex structures. The rest of the course won't focus so much on pseudocode because there's not much to learn about pseudocode and or flowcharts. But more on concepts within programming languages and different paradigms of programming, like object-oriented design, is really where we're heading with some of this. So first thing we're going to talk about is Chapter 8 from the text, where we start talking about arrays. Every programming language has different data structures, Python included. So we're going to talk about the differences and the similarities between them, and mostly more specific to Python's version of an array, which we would call a list. So let's get into it. We're going to break this up into two videos, and again, if you haven't read Chapter 8 yet, I'd strongly suggest that you do so first. Otherwise, we're going to get into this, and we're going to talk about one-dimensional data structures first, and then we'll talk about two-dimensional data structures next. So sorry about that noise there. That was a car going by or something. So either way, the basics of an array, what it does is it allows you to store like a group of information into a single variable. So let's say you've got a whole bunch of test scores that you want to hold on to, and you want to be able to process them appropriately, like sort them from least to greatest, greatest to least, find the minimum, find the maximum, find the average or the mean or the mode or the median, whatever you want. This is one way to do that. So you can put them all together into one big grouping per se, and then we can do stuff to that grouping. So instead of having 50 variables that are all of test scores, or in this example 50 different employees, and they would all need their own variable to store their information, we can have one variable that can store all the information we need, and best of all, that one variable can change in size. So it could store 50 employees one day, 51 employees the next, 45 the next, and so on and so forth, so we can dynamically resize it. So it gives us a lot of flexibility in our programs, and so that's what we're going to kind of stretch ourselves into. So array types, we have two basic array types across most programming languages. We have static arrays and dynamic arrays. Static arrays would be groupings of information that are all of the same data type, which all arrays should be by definition. But the thing here is the number of elements within the data type should never change. So it should be 50 elements, 100 elements, 10,000 elements, whatever it is, but it's that number of elements, and that's how we know. A dynamic array is a little different, where we would again, still have all of the elements of the exact same type, but during the life cycle of the program, while the program's executing, the number of elements within the data structure can change. So it can start with very few, end with a lot, start with a lot, end with very few, or just grow and reduce in size throughout the life cycle of the program. Python has both. We're going to focus mostly on the dynamic side of things rather than the static side of things, because it offers us a little bit more flexibility. So we'll talk about both those data structures as we come in. So declaration in terms of pseudocode, again, it's not terribly difficult, and it's not much different than any other variable. The thing is that data structures, arrays specifically, are indexed, much like strings. So if you recall, our strings are indexed with the first character being at index 0, location 0, and the last character being at whatever the length of the string is, -1. We get all the different integers between 0 and whatever that value might be. Arrays, lists, are the exact same thing. So when I declare an array or a data structure of some sort, I would write the word declare, and then I'd give it a data type, for instance, an integer, real, string, or employees once we get into object-oriented design. And then I give it a name, and I also would tell it how many elements I would expect it to have if it's going to be some sort of static array. So I might do something like this, declare integer numbers of 5. Okay, so now what I have now in memory is a list or an array that can store 5 elements within this single variable called numbers. Somewhere throughout the execution of the program, the processing, I might do something like set the numbers at index 0 to 20, numbers of 1 to 30, numbers of 2 to 40, so on and so forth. And so you can see now this one data structure has 5 different elements in it, all indexed from 0 to 4, because we always start at 0 and we go up to the length minus 1. And so when using them, I have the same variable name, and now I can call upon any one of these elements by a location and index value, like 0, 2, 4, 3, or 1. Doesn't make any difference. So we'll get into an example of how we can access those elements a little bit later, but this is how it kind of draws up in the pseudocode, and this is kind of what it looks like within memory. You've got this one block of contiguous memory that's all called numbers, and this is numbers at 0, numbers at 1, numbers at 2, 3, and 4. Okay? So, like I said, we're going to focus more on the dynamic side of things and the static side of things, but they all kind of set up basically the same way. Python has 2 different data structures you can use. You can use a tuple or a tuple, however you want to pronounce it. That would be kind of the static version of an array in Python. They're pretty easy to set up and instantiate, and I'll kind of show you them, but they don't offer as much flexibility as a Python list. A Python list sets up a lot more like the pseudocode and how it looks with the square bracket notation. But it also gives you a ton more flexibility. Like you can add stuff to it, subtract stuff from it, take stuff away. You can sort it, you can insert stuff in the middle. And those are some of the things that you can't do with a tuple, because the tuple being a static version, also an immutable version of a array in Python, meaning you just kind of have this thing and you can't change it or do anything with it. All you can really do is access its elements. But with a list, not only can you access the elements, but you can also change and modify the elements within, and you can put new ones in or take ones out. Now with a list, you have all sorts of methods that you can use. I'll click on this real quick to kind of show you. I'm just at the Python docs here on lists, and these are all the different things that you can do to a list. You can append things to a list by providing it what you want to append. Appending means simply just add an item to the end of the list. You can extend the list by another list, so almost add a whole other chunk to it. You can insert an item in a list, add a given index with the given item. Okay, so if you want to put something at the very start, you say I want to add this item X to index 0. Okay, you can remove an item from the list, and what it will do is you provide it with the item you'd like to remove, and it will remove the first instance that it comes to with that member of the list. You can pop an element from the list, which is a lot like remove, but instead of removing the first occurrence of an element, you would provide it an index value, a location that you would like to remove, and it will remove the element at that location. You can completely clear the list, so if you want it to just start over and be nothing, or you can find elements in the list. So all you have to do is provide it with what you're searching for, and what it will do is return the very first occurrence of that member in the list. Now, let's say you wanted to find the second or third or last occurrence. You can also provide it with a start value, and that will allow you to start searching at a particular moment in the list, and we'll go through all those. You can count how many occurrences of an element appear in a list. You can sort a list, you can reverse the list, and you can copy the list to just make a replication of it. So we'll go through a lot of these, some of the more popular methods that we'll go through, specifically append, insert, remove, pop, index, and possibly sort and reverse, just so you can see how they work and how they go about. But we'll get into that in just a second. So there you go. When we're processing our arrays, we're probably going to do a lot of looping activities because they're sequences. Our for loops are very, very helpful here, much like they were with strings. So we're going to do a lot of processing with for loops, and again, we're going to give us some examples of that. Specifically, we'll look for some examples that when given a list of scores or integers, we can find the largest or smallest value in that, or maybe even average those particular values. So we're going to take a look at those right here. So if you want to bounce over to PyCharm or whatever IDE you're using, we're just going to kind of go through some examples and how to do it, just to give you for instance. So first thing I'm going to work in is the console, just to kind of give you a rough idea of how this all works. So let's make a list, and we'll just call it something like scores. Okay, and the creation of a list is just like the creation of any variable. Give it a variable name, make it equal to something. But for a list, you need to provide it with a set of square brackets, and then provide it with some elements that are all separated by commas. So let's say you've got like a bunch of test scores. Maybe you scored a 97 on your first test, an 85 on the second, a 74 on the third, a 96 on the fourth, and an 89 on the fifth. Okay, so you've got 5 test scores throughout a given semester, and you want to do some stuff with it. So let's see what we can do. Well, let's put that into memory. So there's my scores, it's logged into memory. If I were to just print scores, just so you can see how it prints, it'll actually just print out the list with the square brackets exactly how you typed it in. Okay, I could find the length of scores. And if I do that, it's actually going to return 5 because there were 5 elements within score. Okay, so 1, 2, 3, 4, 5. So I know exactly how many elements there were. And the nice thing is now I can access specific members of them. So anytime you want to access an element of scores, let's say I wanted to get this 96 from this list. Well, if you think about it, that 96 is at index 0, 1, 2, 3. So if I simply said scores at index 3, okay, give it that square brackets and put an integer in there that's between 0 and length minus 1. When I do that, that actually returns the value that was held at index 3. If I wanted the very first element, I could say at index 0. The 0 is always the very first element, and so there it is, the 97. Okay, so pretty simple to work with. I could also do it and get the last element. Scores at len of scores minus 1. Okay, so I can put an expression in there that would yield an integer value. That's possible. So if I do that, it gives me the last element. But remember, you can also use negative numbers, and it's a little weird to do so, but you can. Scores at, say, -1 will do the same thing for me, so I can get the last element that way. Okay. Now, if for whatever reason you did put in something that wasn't a valid index, like scores at, say, 6. Okay, so if we remember back up here, scores 0, 1, 2, 3, 4, 5, and 6, those indices don't exist. So if I were to type out scores at 6 and press enter on that, well, now it gives me this list index out of range error, and it basically is telling me that that particular element, that particular index doesn't exist for this particular list. Okay, so accessing a member is pretty simple to do. We can actually change these members as well. So for instance, let's come back and let's just reinitialize scores real quick. So I'm going to come back and let's see here. Grab that. We'll bring it down just so that we can see what's going on. Oops. Okay, so there's scores logged into memory. Let's mutate or change some of these scores. So let's say, as a teacher, I made an error and this 85 should have been actually like a 95. Okay, so let's go into scores and let's go to item 2. Okay, and we'll just change it to exactly what it's supposed to be. It's supposed to be a 95, not an 85. Okay, I press enter, and you see it kind of gets logged into memory. And let's just print scores real quick, and you can see that it did not change. Why is that? Oh, it did change. I'm thinking the 85 should have changed, but my bad. That was actually at index 1, and I ended up changing index 2, the 74, the lowest score, to a 95. So it did work. I'm looking at it like it didn't for some reason, but my indexing was off. So this is index 0, index 1, index 2, index 0, index 1, index 2. So I did end up changing index 2 from a 74 to a 95. So sorry for the delay there. So we can change any scores that we want, doing it pretty simple like that. Let's talk about some of the methods that we can do to this. Let's say we had another test, so instead of 1, 2, 3, 4, 5 tests, we had a 6th one that we'd like to add to this list. So we can go something like scores.append, right? And all I can do is just type in exactly what I want to put in the list. Let's say we got a 86 on this last test. So go ahead, log that in. If I were to print scores, you'll see that now it's one item further than what it was before, and now I've got that 86 at the very end of the marker. Okay. For instance, appending isn't the only way to insert items. If I wanted to insert a score in between the, say, 95 and 96, not that that would really ever happen with test scores, but let's just say, for instance, you needed to shove something right in the middle, you could insert. And what I would say here is what I want to insert. I want to insert the score of an 80. I'm sorry, at index, let's see, this is 0, 1, 2. I want it at index 3, sort of push this stuff down. So I'm going to go 3, comma, and I want to put in an 80. And now as soon as I press enter here, whoops, score, it should be scores.insert. And I want to insert something at index 3, and I want to insert an 80 to it. And so now you'll see that we've got that compiled, and now I can print scores. And you're going to see that the 80 actually appears at index 3 now, and everything else beyond that gets pushed down one index. So now my list is dynamically changed from what originally was 5 elements to appending 1 to make it 6 elements, and now inserting a score towards the middle to 7 elements. If I ever want to put something at the very beginning of the list, just insert it at item 0. Insert at 0, and I want to insert a 100. Okay. So I run the line of code, print scores, and now I can see that the 100's at the very top of the list. Okay, so append and insert are great when you want to add elements to a list. Now let's talk about removing elements from the list. So let's say I wanted to go through and remove the highest and lowest score. Okay. Well, the highest score is a 100, so I could easily type something like this and go scores.remove, and what I would type in the remove method is the value that I'd like to remove from the list. Now I want to remove 100 from the list. Okay, so what it will do is find the first occurrence of 100 from the start of the list to the end and just pull it out. So when I do this and I print scores, you're going to see that the 100 is gone. Everything is dynamically shifted to the left 1 unit. The 100 is no longer at the first element. 97 now is. And so let's say I wanted to remove the 80. So I can go scores.remove the 80. And I could type it in and print scores. And there we go. Okay. Now I don't have anything that's duplicated here, but let's just do something that is duplicated. Let's just quickly append an 85 to this list. So we'll go scores.append an 85, just so I have a duplicate element in there, and you can see that now when I print scores. You're going to see that I've got an 85 at index 1 and an 85 at the very last index. Now if I attempt to remove the 85, you're going to notice that when it does it, it actually removes the first occurrence, not the last occurrence that I just put in. So if I print the scores, you're going to see that the 85 is gone from the very first instance it comes across, not the last instance that I just put in. Okay, so there's a lot of manipulation of the scores array. The second method you can use to remove something is the pop method. Now you're going to notice every time I remove something that it doesn't actually print anything after the fact, because remove is what we would call a void method, or just a module in our case. It just does work, and it just modifies the data. The pop method is actually a return method. It actually is a function that gives us information back. So you'll notice that when I use it, something's going to get spit out to the console immediately. So if I go scores.pop, and now the pop function actually requires an index, a location for an element, not the value of the element you'd like to remove. So let's say I wanted to remove this 96 from here. Well, that's at index 0, 1, 2. So if I punch in a 2 here, notice that when I press enter or return on my keyboard, it's actually going to spit out a score for me, and it's going to say 96. Because the pop method will not only remove the element, but also give it back to you in that line of code to be used in some sort of meaningful way. Okay? So if I go and print scores now, you're going to notice that the 96 is missing. but I was able to catch it back in this line of code. So if I had this equal to a variable, I could work with it. So let's go ahead and pop off like this 86 real quick, but I'm going to store it in a variable. So I'm going to go value equals scores dot pop, and the 86 is at index 0, 1, 2, 3. So I'm going to go 3. So you're going to notice that didn't give me anything back because it got stored in value, but if I print value, you're going to see that I have the 86 stored in there, and I can use it to do different things. Like if I want to reappend it or put it back in or put it at the end of the list, I can do that. So I can go scores.append value. And so now it's kind of back in, and if I print scores, you'll notice that I took it out and put it back in at the very end. So I took it out of where it was, and now it's at the very end of where it is. So I kind of, in a sense, almost made a swap between the 86 and the 85. Okay? So appending and insert will allow you to put new things in the list. Remove and pop will allow you to take things out of the list. Now let's talk about how you can manipulate the list in some way and search for a certain piece of information. So if you want to find something in the list, you can index it. So let's say I wanted to figure out where this 85 was. I know there's a score of 85 in this list somewhere. I just need to know the exact location. So I could do this, scores.index, and I could say what value I'd like to look for. Let's say I want to look for a 5 or an 85. When I press enter here, you're going to notice it returns a 3 to me. So 85 was at index 0, 1, 2, 3. Now something to note, if I try to put something in there that isn't in the list, say scores.index, and I type in something like a 90. Notice that there is not a 90 in the list, so let's see what happens here. Okay, it gives me a value error here. It says 90 is not in the list, so it's something you'll have to be mindful of as you go through and work your way through. Okay, I do believe there is a find method as well. Oh, never mind. That was a method for a different thing. But index will be something that you can use to try to identify if something is in the list. And if it's not in the list, it'll cause an error for you to work yourself through. You can sort the list. So real easy to do. You can go scores.sort. Okay. Now there are a couple arguments that you can pass this, like a key and a reverse. But if I just say sort and that's it, you're going to notice that it doesn't really do much. But when I go to print the list now, all the elements are there. They're just sorted in ascending order. Okay. If you want them in descending order, you can sort them and then you could reverse them. So do that, print the scores. And now I've got them in reverse order. Okay. You could do both in kind of the same way. You could always sort in reverse order. So you can go something like scores.sort, and then see how it has this reverse equals false. If you were to change that attribute to true, sort equals true, then it'll sort it for you in reverse order instead of, oops, I said sort. I want reverse. So scores.sort, and it's reverse equals true. So if I run that, then I can see that it's printed and sorted in reverse order. Not that it wasn't already. Oops, scores, not score. And there we go. Okay. So there's some of the methods that you can use to work yourself through and help you with whatever logic you're trying to do. So let's make a quick program here and see how we can do this with an actual data structure that we want to use. So let's call this just a list example. Okay. And then we'll kind of come back to some of it. All right, so let's do this real quick. We'll make a short list of, again, maybe some test scores or something like that. So we'll call it scores equals, and we'll make up a list of scores. So let's say we had a 90, an 85, a 93, a 74, a 67, a 100, a 89, a 75, a 95, and another 90. Okay? So I've got a bunch of scores in there. And let's say I just had some functions that I wanted to be able to do some things with these scores. Let's say I made a function that could find the biggest element in the list. So let's make that function, def find largest. All right. Now in this function, it's going to need to know what this list is. So let's make sure we passed a list into this. So we can call this scores or anything we want. We can just give it a name. We'll just call it our list. And I always like, especially with lists, things that have methods, to use this kind of typecasting that Python allows us to do. And I'll call it a list because then that'll allow me, when I use the rlist dot notation, to bring up in PyCharm all the different methods that the list has. And so our job here is to find the largest element of our list. So return, I should say. Now don't be worried that I'm using a different name here than what I have here. I'll pass scores into our list, and that way this function can be used for any sort of list. It doesn't have to be used for a list of scores. It could be used for a list of areas or perimeters or amount of change or whatever integer value list that you want to work with. So right now it's just find the largest of whatever this particular list is. Just didn't want to call it list. So here we need to come up with an algorithm that can find the biggest value in the list. So let's do this a couple ways. First, we'll do it by index and just looking through every location and identifying what the largest piece is. So first of all, I'm going to initialize a variable called largest, and I'm going to initialize it largest to the very first element in the array because I need something from there to compare it to everything else. So I'm going to go our list at 0 because everything in this particular function deals with our list. And now I want to start looping through everything in the scores array. So I'm going to come up with maybe an index value, and I'm going to set it equal to 1 in this case because I already have our list at 0 being largest. So I'm going to start at index 1 and loop through all the remainders. So maybe while index is less than the length of our list. Okay. What I want to do is compare the element or the value in largest to the element from our list at index. So I'm going to say something like if largest or our list at index is greater than largest, what I want to do is substitute the value from our list at index into largest. And we're just going to let that run through every element in the list. So I'm going to keep index. I'm going to go plus equals 1 so that it ups by 1. And the last thing I want to do is make sure that I return largest. And so now that should spit out the biggest element of the entire array. So let's kind of go through and we'll just try it out real quick. So let's do this actually. I'm going to cut this out and I'm going to make a main method because that's always best. Def main. And in here we'll make our scores array and we'll call this function. Okay, so we'll go max equals find largest of scores. And we'll print the max. So let's call this function real quick, main method, and let's see how it happens. So my main method has a scores array. I call the function called find largest. It returns the largest number, so I catch it in a variable called max, and I'm just simply printing it just to see how it works. So let's run it, see what happens, and it did it. If you look here, it says 100. 100 was the largest element in the list, and I can work my way through. If I were to kind of readjust this list just a little bit, and say I did like an 87, okay, take out the 100, now the largest score should be a 95. Let's run it one more time and see that it works, and it does. It returns 95, and it works just fine. If I wanted this to, instead of printing out the largest value, but the index of the largest value, I just have to make sure I hold on to that information as I wanted to, okay? If I wanted to do something like find smallest, Okay, I could do the same thing, just get the smallest value equal to our list at 0, loop through, and go through it. I'm going to try this again a separate way though. So I'm going to make another function that's like find largest again. I'm going to go find largest version 2. And we're going to be in our list, which is a list. And the reason I want to do this a little bit differently is because I just want to show you a different looping structure that can help us with this. So the pseudo or the idea here is basically the same. Initialize a variable largest to the first element equals our list at 0. But instead of going through by index, I'm going to go through by element, by value. And that's where the for loop really comes in handy. So I can actually really kind of whittle down this code a little bit and do something like this. I can go for score in our list, or for, I should say, instead of score, since I don't know it's technically a score, I'm going to say value in our list. Okay? What this will do, will pull an element from our list and store it in value temporarily for every single value that's in the list. And now I can do the same sort of checking without the indices, which is really nice. So I can say something like, if value is greater than largest, I just want to replace largest with the value. No counter, no control variables, no indexing. It still works really well, and I can finally return largest. So same exact logic, a little bit easier code to work through without the counter, the index, without indexing everything, keeping track of that counter. If I know I'm going to blow through the entire list anyways, might as well use a for loop for it. And for loops are perfect for sequences, and lists are really nice sequences. So instead of max is find largest, I can go find largest v2, and you should see that this actually works identically to what it did before. So it still returns that 95. If I were to plug in that 100 again, it should find that 100 without any issue, and it does. So there's one way to kind of go through that. Maybe one more method just to make sure we're okay with it. Let's create maybe like an average method, or something that could allow us to remove a score if we needed to, or add another score in, or replace a score if we wanted to, or even replace a score. So let's kind of go through maybe finding an average. So we'll go def average, okay, and again we'll go with our list, which is a list. Now an average is pretty simple. An average is just a total of all the elements that I wanted to go through. So I could do this, and I could go with a total equals 0. And my job is to go through every element in the list, add them all up, and work your way through. So I can go for value in our list, total plus equals value. And then my job would be to return the average. Now, make the best out of your return statements. You can put math in these, so you can go total divided by the length of our list. There's your average. So if I wanted to find the average now instead of the largest, absolutely can do that. So if I print, let's do this, delete, we can go average. We'll call it the mean actually. And we can print the mean. Okay. Is this the only way to do it? Absolutely not. Python, if anything, is meant to be simple and use built-in functions to do lots of common tasks, to be perfectly honest with you. So there are definitely other ways of doing it, but I do want to show you kind of the process involved here on how you would go about doing some of this stuff. So there are tons of built-in functions that can do lots of these things. Not that I want you to avoid them per se. I would encourage you actually to look them up and work with them. Functions like the sum function, the min function, the max function. But while you're doing lab and things like that, I want you to focus in on and work on your ability to loop and iterate, check conditions, and index these things, because that's actually really important for you to be able to do, specifically when we start getting into the later modules and we start talking about object-oriented design. So we're going to keep it simple for now, but as we go through, you're going to want to make sure that you're able to work with things appropriately. Okay, so that's going to be it for this video. Please play with some of those methods like the append and insert and remove and things of that nature. The sort obviously could have been used and nicely used in these largists. We could have easily just sorted the array and picked out the last or first element depending on how it was sorted. But that also does kind of screw up the order of things, and if these indices indicate the tests that were given, the first test, the second test, the third, sometimes sorting isn't your best method. So you kind of have to know the problem as you're getting through. So that's going to wrap it up for this particular video. Meet me in video 2 where we start talking about parallel arrays and two-dimensional arrays. So those will be kind of interesting data structures to talk about and something quite useful. So again, play with those methods, the reverse, the sort, the index, pop, remove, insert, and append. Run some other functions like a get lowest or drop lowest or anything like that. And if you have questions, be sure to drop those questions into the discussion thread for Module 7. Otherwise, I will see you in the next video.